welcome. We're on our way here to get the Pilot 511 T511 recapped, and just want to show you how I'm doing this. Normally I don't go to these pains, I just replace the capacitors. This capacitor, this one, this one, this one, this one, and that one are all brand new capacitors, and you're saying to yourself, but they look just like the old ones. What I've done is stuffed brand new Mylar capacitors inside of the old shells, and normally I don't bother doing this, but this radio I want to try to keep it as original looking as possible, merely because it's one of those radios that was a quality radio in its day, and some restorer, hopefully 50 years from now, will open this up to do some work on it, and he will know that it had Sprague and Solar capacitors. And I'll do the same thing with the Electrolytics. He'll know that there were actually Pilot branded capacitors for the Electrolytics. So let's show you how we do this. I start by removing the old capacitor and turn on my heat gun. Now this is one of those Wen Master Mite heat guns for heat shrinking, and this isn't like your industrial paint stripper type. It doesn't get quite that hot. It's a little bit easier to control the temperature with this. And I start by warming up the capacitor. Notice I'm using a pair of pliers so I don't have to stick my finger in there. And the outer waxy surface will start to melt, and I just use a paper towel to start cleaning off the old wax. Makes it a lot easier to deal with. And I'm going to keep heating this or warming this until I notice that the ends are bubbling. You don't want to try to do this all in one shot because you'll overheat the outside. You have to heat it a little bit. Let the heat find its way to the inside of the capacitor, and keep applying heat in little stages. If you're not careful, you can burn it. And again, I don't bother doing this on most radios that I restore. I restore them electrically and I'm done with it. You know, the Zeniths and the Philcos and the ones that there's, you know, tens of thousands of them out there probably, and at least many thousands. If it's not tens of thousands, there's going to be plenty of them. But when you have a radio like this Pilot, which is a little bit more rare, they didn't sell as many of these probably because they were expensive. I'm going to try to preserve the originality as much as possible, even though this won't be seen by most people. The only person who's likely ever to see this would be a restorer sometime in the future. This is my my way of passing it on. Now I'm beginning to see a little bit of melting going on in the end caps. There we go, it's starting to push the cap out. So there you are. There's the inside of your capacitor. And believe me, this cap is dead. All of these are very, very leaky. There's some manufacturer's mark on the inside. So now we have the paper cylinder that says Solar, 0.05 microfarad, 400 working volts. Now I'll show you the next step. Alright, I have a 0.05 Mylar capacitor. Now normally I would use an axial lead cap, but all I have in the junk box for 0.05s presently are these radial lead caps. So I'm going to bend the leads out towards the end so that it will slip into the paper tube. The trouble with modern caps is they usually have very thin leads, although these are fairly robust, but they're certainly too short. The leads that came off of this capacitor were 1.5 inches or better long. So I'm going to extend these leads by using bus wire before I bury this inside the tube, and I'll show you that step now. I've cropped the leads off, the original leads off, very short, and spliced on a bus bar wire of a gauge similar to the wire that came off the original capacitor, and I've put about 2.5 inches, that one's closer to 3, of lead on the capacitor. so that when this is in there, I'll have plenty of lead that I can put heat shrink, or not heat shrink, Teflon tubing, or if this original spaghetti tubing's in good shape, I'll use that. But typically I use Teflon tubing. I have several reels of it, and I don't have to worry about it melting or degrading. So we're going to slip this inside the paper tube, and we'll show you the next step. I missed a step. I offset the leads for capacitors that are really visible. Whoops, sorry about that, camera. I offset the leads so that they'll come out closer to the center of the capacitor, so that it looks a little bit more like the original. Okay, we have our new Mylar capacitor stuffed inside the old case, and this is a little bit easier if you use an axial lead capacitor, but it can be made to work with the radial lead ones. It's just a little more effort to get it in there. I'll slip some Teflon tubing over here because this will be going, these wires are going to be snaking through the tube pins, and I want to make sure I don't have any shorts. The original capacitor had some heat shrink tubing on it, but it was pretty rotten. It was rubberized and it wasn't in real good shape. Now that that's in there, I'm going to take my hot snot gun, and I'm simply going to fill up the end of the capacitor with hot snot, and we'll let that run down in there. Ooh boy, that's getting good and hot. We'll fill a little bit more. And this is a lot of work. This is very time consuming. But for those special radios that you want to preserve as closely as possible to original, when you get finished, it'll be very hard to tell. I usually leave a note inside that tells when it was recapped, and warning any future restorer or any future repairman that these are indeed modern Mylar capacitors, and before you cut them out, make sure they're good, because they've been restuffed. I did do some work on a radio once and had a fellow go in and start cutting caps out after I had passed it on, and he said, "I thought you said this was recapped." And I said, "Take a close look at them. It has been recapped, and if you'd have bothered testing, you'd have known that." At any rate, so there we have it setting up. It's gonna cool down a little bit, and if you really want, you can fill them right up as the stuff runs inside until you've completely sealed them off like the original. And there you have it. One brand new vintage capacitor to go back into your radio, and it will look nearly original when you're finished. And as we build up another one here, I know somebody is going to regale me for, or chide me? I don't know. Anyway, somebody's going to be upset that I'm not using black spaghetti tubing like the original. It's my radio. I'm going to use what I got on hand. I've already spent a lot of money on this radio that I'll never get back. And I know it's not about the money, it's about saving the radio. At least in the future they'll know what it had for capacitors. Somebody's also bound to ask me what the voltage rating of the caps I'm putting in is. These Mylar caps that I'm using to stuff these are rated at 630 volts. The paper caps I'm removing are rated at a mere 400 volts. And in actuality, this radio will never develop, or could not possibly develop, a voltage any higher than about 165 volts. Now, why is that bubbling? It must be an interaction with the wax. There's no power transformer in this radio. It merely has a half-wave rectifier on the line, and if the load was completely removed from the power supply, the possibility is there for the capacitors to charge up to peak voltage. Now when you have 120 volts, it's actually, that's RMS, or root mean square value. the peak voltage is actually considerably higher. However, that's not important. There was 400 volt caps. We're replacing them with 630 volt caps, but in reality you'd be perfectly safe with 200 or 250 volt caps in this particular receiver, because the voltages will never get that high. And boy, my glue gun is really up to temperature. This stuff's running like honey right now. Normally it's a lot thicker than this, but with the glue gun's been on for an hour or two, and this stuff is really getting hot. So anyway, we're going to put this cap in and move on. And one other thing I wanted to cover before I went away here. Adam has jumped on me for calling this a chassis, and I guess rightfully so. I guess the S is silent. It's chassis. But when I grew up, everybody I know in the town that I grew up in called it a chassis, whether it was your car or a radio, and we just got in the habit of that. It's like the my aunt or aunt. I grew up, everyone I knew said aunt, and when I got into school, the teacher was from another part of the country, and boy did we catch the dickens for saying that. It's aunt. You have to say aunt. Let's see, what else is there? Oh, some people say solder. And of course I grew up, believing it was supposed to be solder, and I still do. But there are people, and Paul being one of them, who calls it solder, and that's his right. He can call it anything he wants. But Adam, I'm just teasing. I'm not upset, buddy. I took it as it was meant. Trust me, I'm not upset with you, buddy. Okay, we're going to stick this one in. While I'm working here, we'll answer a couple of questions. I have had a couple of people ask me what I use for soldering iron. And when I'm working on this vintage gear, I prefer to use my old Weller gun. I grew up with one of these in my hand, and perfectly comfortable. I shape my own tips, and I'm perfectly comfortable getting down in behind the wiring with these. I've been using them for so long. I do have a Heiko 928 dual controller. One control has a pair of tweezers for SMD work. The other controller uses a standard Heiko pencil iron. But my normal go-to one is my Weller WTCPT, which has the temperature control in the tip. And when you've been doing this for a long time, you just get used to certain tools, and they work well for you. I love these because the solder connections in these radios, especially on the tube pin socket, where there's 6, 7, 8 connections on a tube pin socket, these have the heat capacity to get in, get out, and get the job done, as well as they're a narrow enough tip to get in there. Plus, when I lay down on the table, I don't have to worry about a hot iron plugged in. Within a few seconds it's cool and out of the way, especially when you work in such a messy environment like I do. But that's what I use for soldering irons. As I've been taking apart these 0.05 microfarad solars, there's been a little paper tag on the inside of each one of them, and they were, in this radio, happened to be labeled 47, 48, 49, and 50. And does anybody know the history? What those numbers signify? I've, often see the numbers in there, but it just dawned on me that, I figured they were an assembler, assembler 20, assembler 30. I never paid any attention, but these were in sequence. So evidently all 4 of these capacitors came from the same lot, I'm guessing, and they were 47, 48, 49, and 50 is the order they were built in. I don't know. Anybody has the answer to that, definitive answer, guesses are great, but if anybody has a definitive answer to that, let me know. I'll be curious to find out what that's all about. All of the capacitors are changed out, with a couple of exceptions, and we'll cover that in a moment. Every one of the paper capacitors in here was basically a resistor. I mean, they were terrible. Some of them wouldn't even read capacitance when I pulled them out. I checked them all just out of curiosity. I knew they were bad, but I wanted to see how bad. Some of them were just absolutely not even showing capacitance anymore. You couldn't find a point where they would read capacitance, and they were leaking voltage heavily at the 25 volt level. So at any rate, all of the paper caps have been changed. Then I went to test, or to change the electrolytics, and if you remember, when I turned this thing on, there wasn't any hum. I mean, there was hum when it was all the way wide open, but that's normal for a half-wave rectifier set. If it's wide open and there's no signal, you're going to hear some hum. So I decided before I ripped them out of here, I'd test them. And I know as a matter of course you should just change them anyway, but I wanted to see what they were like. First I checked them for capacitance. They're labeled 40 microfarads. They were both reading about 50 microfarads, which is fine. That's normal, absolutely normal. Then I did a leakage test, and the leakage test passed with flying colors on both of these. Then I did what's called a power factor test, which is basically the old version of ESR. The Heathkit uses what's called a power factor test. They tested perfectly. I mean, they were like new capacitors. So then I got out my ESR meter and I tested them for ESR. Again, they tested under 1/10 of an ohm. They were both like brand new capacitors. So after running all of those tests, I said these have to be bad. So I went, and up here I used my Sencor. I have a Sencor capacitor tester, professional unit up there. And I did what's called a dielectric absorption test. And that's the test, it's a test you can do to see if the electrolyte is drying out in these capacitors, if they're due to fail anytime soon. They may be testing good, but they may be on the verge. And the way you do the dielectric absorption test is you check the capacitance of the capacitor, note the value, then you do a leakage test, which impresses a high voltage, in this case 200 volts, on the capacitor. And immediately after releasing the button for the leakage test, you again note what the capacitance value is, and if the capacitance value has dropped appreciably and then slowly begins to climb back up to its normal value, that tells you that the dielectric is drying out in the capacitor. But if when you release the button, if it immediately jumps back to the original capacitance value, that means the dielectric's in pretty good shape. They passed with flying colors. It's like it's like they just left the factory. It's incredible. I've never seen electrolytics this age that tested this good. Since this is my radio and it's not going anywhere, I am going to leave these in here for the time being, at least. And when I play the set, I won't leave it unattended. I'll listen, and if I begin to hear humming, I'll know the capacitors are starting to go away. And probably with this set, worst case scenario, if one of these was to go dead short, I might cook the rectifier, and I'm not worried about that. I've got a box full of them. I don't think this will do any other damage. There's no power transformer to worry about. It's connected right to the line. So what have we found? We replaced a couple of resistors, and one of them, let's see if I can remember what's going on here. This is a 47 ohm resistor, which is right here. That was reading about 57 ohms, not a big deal. I replaced this one here, this 330K resistor, which is, where is it? Doop-de-doop-doop-de-doop. Right here. No, wrong one. I'm looking at the wrong one. The 330K resistor right here, what supplies the plate voltage or the plate current to the detector tube. That was running about 450K, about 100K high, so we changed that one out. We had another resistor. Oh, which one was it? hang on a second, let me go back over the schematic. I think I misspoke earlier. This is a 4.7K ohm resistor, and this was reading, trying to remember now, it was almost 6K. It was a couple of thousand ohms high, and I changed that one because that one is the AGC line for the converter, so it sets the bias wrong on the converter grid. This 330K resistor over here is running a little bit, was running a little bit high as well, so we changed that one out. Now there's another, this 47K resistor right here, which is in the detector circuit, is running about 57K. It's about 100K high, or excuse me, about 10K high. That feeds the audio circuit, and there's two capacitors in here. I was wrong about capacitors never having been changed. I had thought originally these were those resistors that have that sandy feel to them. It was before I looked at the schematic. Then I realized these were capacitors. These had been changed. These are 0.02, and it's supposed to be, this one's supposed to be a 005, and it's now a 0.02, and this one up here is supposed to be a 0.01, and it's a 0.02. 02 and 02 where there's supposed to be a 005 and an 01. Now I think this may have been done to boost the audio because they had problems upstream. The high values here were causing losses of gain in the IF stage. So we'll see. I've left these two capacitors in here for now, and I've left this resistor in here for, or excuse me, no, this 470K. Boy, I'm getting all balled up tonight. This 470K, which sets the grid bias on the power amplifier, is running about 100K high. I'm probably going to end up changing that, and I might end up changing these two capacitors to the correct value after I hear the set run. As you heard in the previous audio, the tonal quality of the set was quite good. Actually, it sounded pretty well, pretty nice for one of these radios. It was a one-hit wonder. We had a dead converter. We had a bunch of values in here that were incorrect on resistance. But the audio chain sounded pretty darn good. So I am going to take a voltage reading on this control grid when we get this thing up and running. And I might change this resistor to its proper value, and I may end up having to lower the value of this. We may have too much audio now, which could lead to distortion. But it sounded good before, so I left those capacitors in there. And again, I'm assuming they put these in to compensate for the lack of sensitivity of the set. I have not powered this up yet. I want to go one more time through the schematic, make sure I didn't make any wiring errors. I did one component at a time. I don't think I did, but we don't want any smoke when I turn this thing on. That would be embarrassing to have it smoke on camera. Because you'll be with me when I power this thing up. You'll be with me for the alignment. We're going to do this at the $10 test bench and bring this thing up. And I'm getting tired, you can tell. I'm making a lot of mistakes right now. I've been at this all day long, and I need to go upstairs and get something to eat. Oh, yes, I did some work on the cabinet today, too, in between. I walked away, and we're going to do another video on that. I did some work on the cabinet. We still have a couple other things to clean up. But we're getting close. We're getting darn close to putting this thing together. I guess that's it for tonight. I'm going to try to put this together, edit it, find out how many mistakes I made in talking here, because I'm getting a little spacey. We cleaned up everything. The bench was a mess, so we spent some time cleaning the bench up as well. Anyway, I'm rambling. I'm the Radio Mechanic. Thanks for stopping by, and stand by for the next installment. It shouldn't be too long. See ya.